Welcome to the Ansible Architecture and Capabilities module. By the end of this module, you should be able to explain how Ansible manages network devices. Ansible is a configuration management solution that was used initially to deploy, configure, and manage compute resources. Over time, Ansible has been extended to provide similar services to networking devices. Idempotence is an important concept in configuration management. Idempotence means running the same operation multiple times yields the same result. Executing the same Ansible playbook multiple times without changing anything after the first execution causes no changes to occur. Ansible playbooks can be processed using DevOps toolchains to optimize new deployments. For example, playbooks can be checked into a version control system such as Git to ensure playbooks can be rolled back to previous versions if necessary. You can also use continuous delivery tools such as Jenkins to validate playbook functionality. Ansible normally uses SSH to connect to remote hosts, copies the relevant Ansible modules, typically Python code, and performs tasks on the hosts. There is no agent or client needed on the remote hosts. Only a Python interpreter is required for a host to be successfully managed. Ansible Python modules use YAML ain't markup language or YAML playbooks to perform tasks. Once the tasks are complete, the Python modules are deleted from the host. When using Ansible to manage Junos devices, the Ansible Python modules are not copied to the Junos devices. Instead, the modules are executed locally on the Ansible server, and Network Configuration Protocol or netconf over SSH is used to perform the automation tasks on the Junos devices. Ansible is installed on Linux, OS X, or BSD operating systems. Windows is not supported. Ansible is written in Python and requires Python 2.6 plus or Python 3.5 plus to be installed. Install Ansible using the Python pip or the pip3 command for Python 3. To manage Junos devices, the Junos PyEasy and JXML-ease Python libraries are also required. Finally, the Junos devices need netconf over SSH enabled under the Edit System Services branch of the configuration hierarchy. Ansible modules are pieces of code that are typically written in Python. The modules contain functions that are called to perform specific tasks. You supply various parameters for the modules at runtime. Ansible includes some core modules that are part of the Ansible module library to perform common tasks, such as gathering host facts, installing packages, deploying configurations, and many others. These modules are supported by Ansible and the commercial Ansible version called Ansible Tower. Beginning with Ansible version 2.1, Junos modules are included as part of the Ansible module library. Ansible's functionality can be extended by downloading modules from a repository called the Ansible Galaxy. Ansible Galaxy modules are organized into roles. A role is Ansible's method of bundling automation content together and making it reusable. Junos modules are available in the Ansible Galaxy Juniper.Junos role that includes additional functionality. Examples of Ansible core modules and modules available in the Ansible Galaxy repository are shown. The functionality of some of the modules in the Ansible module library and Ansible Galaxy overlap. You can mix and match module types, even in the same playbook. Choose the one that best meets your needs. Modules in the Ansible module library are developed, maintained, and supported by Ansible. Modules in the Ansible Galaxy Juniper.Junos role are supported by Juniper. To use the Ansible Galaxy Juniper modules, install them on the Ansible server using the Ansible Galaxy install Juniper.Junos command. Ansible inventory files contain a list of hosts and host groups that Ansible can manage. The example inventory file includes the VMX1 and VMX2 devices that are managed by Ansible. Managed devices can be listed using names or IP addresses. Typically, a fully qualified domain name is used that must be resolved to an IP address. Inventory groups are defined using square brackets. In the example, a group named VMX devices is defined that includes the two VMX devices as members. Groups can be nested, and a device can be a member of multiple groups. Inventory files can contain variables that reference devices or groups. Alternatively, variables can be placed in separate directories named group vars and host vars. Ansible's default inventory file is /etc/ansible/hosts. You can provide an alternate inventory file as an argument when running Ansible, using the -i key. This enables you to organize devices into different inventory files, or have separate environments managed by the same Ansible installation. Welcome to the Ansible Playbook Basics module. By the end of this module, you should be able to describe the basics of an Ansible playbook. Ansible playbooks are written using YAML, Ain't Markup Language, or YAML. They contain instructions used by Ansible modules that enable administrators to automate workflows on multiple devices. A playbook contains one or more plays. A play combines an inventory of hosts and a set of tasks that must be performed on those hosts. Each task uses a specific Ansible module to do the job. The primary Ansible components include an inventory file, playbooks, modules, and an Ansible configuration file or ansible.cfg. The Ansible configuration file enables you to define optional Ansible parameters, like connection timeouts, SSH session parameters, and so on. The example shows a basic Ansible playbook used to manage Junos devices. The hosts are a group of two VMX devices defined in the Ansible inventory. The Juniper.Junos role is imported, making the Juniper Ansible Galaxy modules available. The example shows a more complete Ansible playbook that instructs Ansible to connect to the VMX1 device, retrieve basic Junos device facts, and print the facts to the terminal. Note that Ansible playbooks are written in YAML for simplicity and readability. The playbook is run using the Ansible Playbook utility, with the playbook name as an argument. Ansible displays output for each task, as well as the results of any changes. Welcome to the Using Ansible to Retrieve Junos Status Information module. By the end of this module, you should be able to explain how to use Ansible to retrieve information from Junos devices. There are multiple methods that can be used to retrieve Junos device status information using Ansible. This module focuses on using Juniper's Ansible modules from the Juniper.Junos Ansible Galaxy role. Note that Ansible library modules could be used for many of these examples. The Juniper Junos Facts module is used to collect basic facts from a Junos device. You can also execute Junos CLI commands using the Juniper Junos command module or Junos Remote Procedure Calls or RPCs using the Juniper Junos RPC module and collect the same output. Output can be printed to a terminal or saved to a file system. The Ansible Galaxy Juniper.Junos role also has modules supporting Junos PyEasy tables or views. Juniper Junos Table and Juniper's JSnappy tool, Juniper Junos JSnappy. Based on the retrieved information, you can perform asserts using Ansible's assert module that perform checks for different conditions that must be met on the devices. The example playbook uses the Juniper Junos command module to execute a Junos CLI command on a group of devices containing VMX1 and VMX2. The output is printed to the screen. The Junos show interfaces GE0/0/01 asterisk terse command is executed. Note that the asterisk ensures that logical unit data is also retrieved. You can easily replace this command with another Junos CLI command. Running the playbook displays the interface output shown on the screen. The output includes interface information from both devices. Welcome to the Using Ansible to Retrieve and Modify Configuration Information module. By the end of this module, you should be able to explain how to use Ansible to configure Junos devices. The Juniper Junos config module from the juniper.junos Ansible Galaxy role can be used to perform configuration management on a Junos device. You can retrieve, load, rollback, and commit configuration using XML, Junos set commands, ASCII text, or JavaScript object notation or JSON. You can manage device configuration in either exclusive or private configuration mode. The example playbook demonstrates using the Juniper Junos config module to retrieve the Edit Interfaces portion of the active configuration on the VMX1 device. The filter parameter is used to make sure only the interfaces portion of the configuration is retrieved, while the retrieve parameter ensures the active or committed configuration is analyzed. The register keyword is used to save output to a variable, and the debug module is employed to print the output to a terminal. Note that the response variable contains response.config line syntax to normalize the output to only include configuration data. The example displays interface configuration from the VMX1 device. This example uses an Ansible playbook to deploy Network Time Protocol or NTP server configuration on multiple Junos devices. There is only one NTP server IP address and no additional NTP parameters except the IP address must be configured. It is not difficult to extend this example to include a list of NTP servers and additional NTP parameters. The NTP server IP address should be modifiable without needing to modify the playbook. In line with Ansible best practices, the NTP server address is stored in a separate location. This example stores the NTP server IP address in the inventory file using a group-level variable. The group name vars syntax is used to define the NTP server variable and the NTP server IP address value. The NTP server variable is referenced in the Ansible playbook. This enables the NTP server IP address to change without needing to modify the playbook. Devices that are members of the VMX devices inventory group can use this group-level variable. This example uses the Juniper Junos config module to load a partial device configuration that includes NTP parameters in XML format. The playbook enters the configuration mode using the exclusive option to obtain an exclusive lock on the configuration database while Ansible performs configuration tasks. Because this is a partial configuration, the replace method is used to load a candidate configuration. The lines option identifies the configuration data, and the format option identifies the configuration data as XML. The commit parameter commits the candidate configuration. Note that the candidate configuration includes the NTP server variable that is used to define the actual NTP server IP address. When the playbook is run, devices that did not have the correct NTP server configuration have the configuration applied. The configuration difference output demonstrates that the NTP server configuration was loaded successfully. Note that the changed equals 1 value in the play recap for each device. Each Ansible module typically returns a Boolean value indicating if the managed device was changed by a given task. Remember that Ansible is idempotent. If you run the playbook again and nothing has been changed since the last time the playbook was run, no change actually occurs. This is indicated by changed equals 0 as well as the empty difference output. You decide to modify the NTP server variable in the inventory file and run the playbook again. This time you should expect to see changes on the devices. The previously provisioned NTP server was removed and the new one was provisioned. Note that the existing NTP server IP address configuration is being removed because the playbook uses the load::replace method. Otherwise, you end up with two NTP server IP addresses configured on the devices. The same playbook is run again. The difference output shows the existing NTP server IP address, preceded by a minus symbol, indicating that it was removed from the device configuration. The new NTP server IP address is preceded by a plus symbol, indicating that it was added to the device configuration. This module discusses the basic features of Ansible and how you can use it for automating Junos. There are many more features, capabilities, tools, and methods available.